Okay, so I'm just messing around with my PIC10F200, hoping to try some assembly language programming, but before I get into it, as always, I have to navigate through MPLab because it's always a challenge. Note to self to check part 8 in the playlist. So really quickly, new project, standalone project, 10F200, no debugger, PIC-kit, okay, now I go to new file. I guess I click assembler. This one, assemblyfile.asm. I guess I'll call it so. I guess it should be set up. I'm going to paste in some code I used before. Okay, it's successful. Now I'll try to upload it. Connection failed, probably because of the power issue. Okay, so I go File, Project Properties, PIC-kit 3, Power, Apply. Okay, try uploading it. So that didn't work, so now I yoinked out the USB port. Hit OK. I don't know, but I pulled the USB out and plugged it back in and it worked. So either the power setting or getting the software to recognize the COM port USB did something. Alright. So here is some code I developed. I'm still a novice, but I am proud that I got this to work. So I will go through this step by step. So number sign include PIC10F200.inc, the configuration bits. I set the mclear as to off, code protect is off, watchdog timer is off. The origin of the code is 0x00. So we are initializing the microcontroller over the next 2 lines. So move a literal value, and I suppose these first 4 bits make no difference because it's unimplemented, but this is the least significant bit, which is also GP0. So we're setting GP0 as an output and GP1, 2, and 3 as inputs. And then it just takes this value, which is now in the working register, and puts it in the trace register. And I take it the trace register in the 10F200 is called GPIO, whereas maybe some of the more advanced chips might say port A, B, etc. And here's the simple code I wrote. So the label is called again because I want this to loop, so it makes sense to call it something like that. Bit test F set if clear. bit test filereg skip if clear. Bit test filereg skip if clear. And it's testing GPIO, and specifically it's testing GP1. Here are the pinouts in the data sheet. GP1 is pin 4. So this is set up as an input, and it's going to test the state of this. Whatever state it's in, through the code as I've written it, it'll put the output on GP0, which I've configured as an output pin. So when it bit tests GP1 pin, which is pin 4, it'll skip the next line of code if GP1 is a low or if it's clear. And no matter if it skips or proceeds to the next line, it ends up setting and clearing GP0. And then it just loops go to again. Loop back to again. And then the code is ended. So, as will be seen in the practical example, I use a push button which has pull up and pull down resistors on it to add as an input into GP1, and then I switch it out for a 555 timer circuit rather than a push button, so my finger doesn't get tired. That was a joke. Me having a tired finger was the joke part. Okay, thank you for watching. I'll leave the sample code below, and hopefully the data sheet and whatever else I think might be helpful to you. Thank you for watching. Of course, I'm not an expert. I'm a novice still.
Okay, good evening. So I'm just demonstrating that the input on GP1, which is set up as an input, is going to affect GP0, which is set up in the program code as an output. So I won't completely explain all my circuitry the way I have it set up, but I will comment that on this development board that I created, there is a pull down resistor, and this is not connected to the chip. This is just a separate module I put on the board. So there's a pull down resistor hooked up to this female header, and if I push this push button, there's a pull up resistor. So it'll change a signal in the female header from a low to a high. So this module is hooked up to pin GP1, and the way the code is set up, the output will show up on GP0. So if I push the push button, it lights up the LED. So what if I don't want to use a push button to do that? And instead of the push button, I'll unplug that. I use a 555 timer circuit. So I built myself a 555 timer module, so I wouldn't always have to construct the circuit again. And here's my 555 timer here. And I have a breadboard set up just so I can put a resistor, 220 ohm, on the 555 timer output, because because I don't want to risk blowing the pins. So anyway, now there's an output from the 555 timer through the breadboard, through a current limiting resistor into GP1. And once again, GP0 is the output as it's configured in the code. Now the way I had my 555 timers set up, I can adjust the blink rate.